Alright, hello once again, Jeff Scott of Rankin Technical College. I'm going to be going over the last chapter, Chapter 14 of Farrell's Microsoft Visual C# 2015, An Introduction to Object-Oriented Programming. There appears to be something wrong with the sound, so I'm coming on with sound. My voice is sounding deeper and slower than it actually is, so I don't know what's going on with it. In this last chapter, we learn about computer files, the file class, and the directory class. We learn about file data organization, what data streams are, how to write to a sequential access file, how to read from a sequential access file, how to search a sequential access file, and the differences between serialization and deserialization. All right, little hardware to throw at you as we start. You should know this already, but the memory of your computer is known as RAM, random access memory. It's temporary, meaning that it's volatile, meaning that it's subject to electronic current. So in other words, if you run the program, so if we run any of the programs that we've created so far this semester, and we run them, and then we stop the run and we close our window, the results of that program are gone. So if we want to save the results of a program run and we want a permanent result, we want something that's non-volatile. So we have to save it to either a file or we have to save it to a database. So a computer file holds a collection of information. A text file is something in Unicode format that you can read. Now they also show here, and I'm not going to read these off to you. All right. They don't even mention this, but a byte actually holds 8 bits. Each bit is a 0 or 1, and putting those 8 zeros or 1s together gives you 1 byte or a character of information. A kilobyte is actually 1024 bytes, but it's typically set in there 1,000 bytes. All right, mega, giga, peta, or a tera rather. There's petabytes, and it even goes bigger than that. Some of these machines, like Cray supercomputers that are used to forecast the weather or used by the Defense Department, they work with even bigger numbers than these. All right, so again, you've got two different types of files. You've got text files that contain information that you can open up with a simple text editor. All right, so in other words, if you look at this, if I come through here and grab this file that I'm working with here, so if I grab this file that I'm working with and I open it up, all right, so if I come over here, and instead of saying open like this, I say open in Notepad, it's going to look like garbage. That's the file. But since the file isn't in a Unicode format, it's in a binary format, which means it's in some kind of format where it can only be read. It can only be read by the software that understands it, and this software evidently does not understand it. So the information is in there, but not in a format that we can understand. If we look in here, on the other hand, what you see when we come here is this is file in a text format. All right, now it's a .cs, but .cs files are literally saved in a textual format. All right, so you can read them with a simple type of text editor. Now, when you start to work with files, be they binary files or text files, all right, you typically, and the stuff that's in here is more with text files, just so you know. But you want to be able to write to a text file, read from a text file, and sooner or later, as time goes on, if you've got so many files, it makes sense to organize them into some kind of a folder or directory structure. Now, back in the day when we weren't working with things that were GUI, that were graphical in nature, we talked about directory structures. Today, more often than not, they're just referred to as folder structures. At the top of the folder structure or the directory structure is your root. It's the only folder that doesn't have a parent. All right, everything you put underneath the root is going to be either a folder or it's going to be a file. And again, a folder is also known as a directory. How you get to that folder or that file is known as the path. So this would say that I want to find this file called data.txt. It is under the root, and under the root there is a folder called C#, and under C# is a folder called Chapter14, and under that is our file. So that's the path. C# has built-in classes named file and directory that you can use to help you with file manipulation, directory manipulation, whatever you want to call it. Folder manipulation. So it allows you to access file information. You might want to check a file's type before you attempt to read it using some kind of software. It allows you to create files, delete files, and move files. Remember, we talked about this earlier. There are two basic ways that you can save information, also known as persistent data storage. This chapter talks about files and data streams. What this book does not go over is the way that's used probably more often, and that is databases. All right, so the file class, as it says, it's in the system.io namespace. So if you put using system.io semicolon at the top of your program, you can use anything that's in there. All right, it contains file information. The directory class gives you information about your directories, again, also known as folders. So here's some of the file class methods. I'm not going to read any of these to you. These, in many ways, these are very much like operating system commands. Create something, delete something, move something, etc. So here's an example. Now, what's important here is we're telling the user to enter a file name, all right, and then we're reading it in. But what we're saying here is we're telling the system where the file exists, we're telling the system to go out and look through the file system to see if a file by that name exists. So we put here, we need the using system.io, so we enter a file name called myletter.txt. There isn't a file on our system called that, so it comes back and it says file does not exist. So it hits the else. Then we run it again and we type in businessletter.txt, and that file is there. So it says file exists, file was created, and it tells us the date on which it was created. File was last accessed, so it tells us the date it was last accessed, and the file was last written to, and it tells us when it was last written to. So you notice that this file was both created and last accessed on April 6th, but last written to, so this was April 6th of 2015, but last written to on June 24th, 2016. You might say, well, wait a minute, how could it be accessed and written to be different? There might have been a program that did it, where the file technically wasn't accessed by you, but it was written to by another program, and that happens. So here are some directory class methods. Again, I'm not going to read these to you. I'll leave them up there for a second. So you'll notice that one that's down there, we've got get files. So if we provide the system with the name of a directory and we call get files, it'll show us as an example every single file that exists in that directory. So this is similar to the last example we looked at, but now instead of asking the user to enter a file, the file name like we did, we're asking them to enter a directory name. And if it exists, we'll give them the information. If it doesn't exist, we'll say it does not exist. So we say customer info, and it comes back directory does not exist. we say client memos. It exists and it contains the following. And we go through and we put this into a for loop, and it gives us a list under client memos of every file that exists underneath there. It is a way that you can very quickly go through and find out if files, like mentioned there, do exist, what directory structures are like, what file types are like, etc. This all leads to, again, as you're building things, you know, for instance, if I come through here and I look on my own system here, all right, which isn't set up very well, but just so you see it. As an example, I've got PSD to HTML students. So there's a file that's under my desktop, a folder. If I go in there, I've got a thing called PSD homework. If I go in there, I've got homework 1, homework 2, homework 3, and homework 4. If I go into homework 4, I've got another folder and I've got a file. If I go into that folder, I've got a bunch of files and 2 more folders. So you can see I'm getting very deeply here. I'm getting very deeply into my folder structure. All right. Let me make this a little bit bigger so you can see it. Can't make it too big because it's long enough. I can make it probably a little bigger than that. All right. So what that's saying is we take a look at this. Sorry. What that's saying is we're going through this is, okay, this C:users Rankin, that's my root. So I'm on the desktop underneath that. And under that, I'm under a folder called PSD to HTML students. And under that, I'm at a folder that's called PSD-homework. And under that, I'm at a folder called HW4. And under that, I'm at a folder called Udemy course files. And under all that stuff, so if I was looking for this PDF, that's where I'd find it. And again, I could write a program that would search for that. So when we start talking about a data hierarchy, this is interesting because they're almost showing you terms that I would more equate with databases than with files, but I don't disagree with what the author has done here. All right? So a character is literally, typically it's something that you key in. All right, but some characters exist that you can't even key in. If you take one or more characters and you put those one or more characters together, they constitute a field. So in other words, this person's last name is Lee, L-E-E. All right? So a character is a single character that you either can or cannot type in, but it has typically some meaning. If you put one or more related characters together, you get a field. If you put one or more related fields together, you get a record. If you put one or more related records together, you get a file. The only way that this differs from a database is in a database, the character, field, and record are the same, but in here, instead of calling it a file, we'd call it a table, and we'd go up one higher and we'd call it a database. All right, so there's the authors. Again, I'll leave that up there for just a minute so you can see it. Now you'll notice they talk about sequential access and random access. Couple things about this. Much easier to write programs in sequential access because you're reading stuff in order. You need some kind of a key field when you do that typically. The bad thing with random access is, let's say that I've got a program and it's got 1,000 records in it. And I discover that record 510 has got an error in it. Then what I have to do is I have to write a program where I grab the first 509 records and I write them to a new file. I fix record 510, write that to a new file, and then write the other 490 records in. With a random access file, the records don't have to be in any sequence, and you can access them in any order you want. The bad news about a random access file is that records have to all be the same size. Now, I'm going to say something, and this is dating myself, so some of you will understand this and some of you won't. I watched an old episode of Blue Bloods on TV a week or so ago, and as the family does in there, they were sitting around their kitchen table, and they were talking about music and different songs, etc. And one of them was talking about when they were younger and how they had a cassette tape. And the young kid said, "What's a cassette tape?" Well, hopefully you know what a cassette tape is. But if I've got a cassette tape and I put the cassette tape in, and let's say that on the front side of the cassette, it's got 10 songs, and I want to listen to song 7. I've got two choices. I either have to, if I'm at song 1, I either have to listen to the first 6 songs before I get to mine, or I have to fast forward past the first 6 to get to the 7th. On the other hand, if I use a CD and I want the 7th song, I just put in a 7, program that in, and it jumps right to it. So using cassette is more like sequential access, and using a CD is more like random access. All right. A C# application opens a file by creating an object and associating what's known as a stream of bytes with it. When you finish with a file, you should close it. If you don't close it and the program ends, the file will be closed for you. The problem is, while that file is open, it may be inaccessible to other people, and it's still subject to electronic current. So if I'm opening up a file, and it's a big file with a bunch of customer information, and I'm writing to it, and I forget about it, and I go to lunch, and there's a thunderstorm at lunch, and it hits the computer, it's possible that that file could become corrupted or even be destroyed. So again, we're working with streams here, and as it says, the stream functions as a pipeline or a channel between an input device, and the input device we've been using thus far in our program has been our keyboard or our mouse. But now we're going to grab input that already exists from a file. Or so far, when we've when we've had any output, it's been on the screen. But we're either going to get input from a file or send output to a file, or we're going to do both. If we get input from a file, it's an input file. If we put output to a file, it's an output file. But the same file can function as both an input file and an output file as well. So here are some of the default streams in C#. Console.in, which is the keyboard, by default. Console.out, which is your computer screen by default. And standard error, which is also your screen by default. Most streams, as it says, flow in only one direction. So the stream reader is associated with input, the stream writer is associated with output, the file stream, as it says, is used alone for bytes with either stream reader or stream writer. All right. To understand streams, here are some properties. Can read. That says whether or not this file stream supports reading. Can seek. What seek means is that's typically used again with random access files. That allows you to jump to to whatever record you want. Can write, the opposite of can read. Length, which gets the length of the file stream in bytes. Name, which is the name of the file stream. And position, where you currently are. Sometimes also called the file pointer. All right. File mode. You can open up a file in a pen mode, which means that you can read from it and you can write to it. You can open it up in create mode. If you open up a file in create mode, if the file does not exist, it's created. If the file already exists, the file pointer is moved to the beginning of the file. So as soon as you start to write, it removes whatever contents were there. Create new, which creates a new file if it doesn't exist, but if the file by that name already does exist, it throws an exception. Open opens an existing file if it exists, and if it does not exist, it throws an exception. Open or create, it either opens a file if it currently exists, or it creates it if it does not exist. Truncate opens a file, then basically removes everything that's in it. All right, we've got read mode where you can read from a file, write mode where you can write to a file, and read-write where you can both read from a file and write to a file. Now, you are good, again, I know it's a broken record, but you're going to have to read the chapter because they show you here how you set up a file stream and then how you associate that file stream with a stream writer in this case. All right, that says enter some text, you read the text in, and boom, it writes it. We're used to saying just write line, but now we're saying write.write line. All right, or writer.write line, and that's our stream writer. So instead of this information being written on the screen, it will be written to a file. When you're done, you close your writer, which is your stream writer, and you close out file, which is your stream reader or stream writer. So C# is mentioned there, uses files only as streams of bytes. When you write a program to store data in a file, you must tell it the form the file will take. When you're writing data to a file, you create a file stream object. All right, writing data to a sequential access file. Well, quite often when you write data to a sequential access file, you might use something as mentioned here at the very bottom of the slide, and that is a CSV, which are comma-separated values. So they're delimited. All right, every time I write something out, in fact, look at this. Here's an example. This is tokenized in here. Okay, a block of text within a string that represents an entity or field. All right, the delimiter in here is a blank space. Sometimes that gets very hard when you use a blank space as a delimiter. So typically when you write data to a file, you don't use a blank space. Quite often you separate each field, where like we're separating each word here with a blank space, you separate each field with a comma. If you do that, you have CSV files. So we're going to write employee information. All right, we're going to write a number, a name, and a salary. And when we do that, we're setting it up so it's going to be a comma-separated value file. And you notice number, comma, name, comma, salary, number, comma, name, comma, salary, number, comma, name, comma, salary. All right, so that's an example here in this program of writing data to a file. If we didn't do that, we'd be writing it onto the screen here. So we are changing our standard output device. We are redirecting it from the screen to a file. So reading from a text file is similar to writing, but you still use file stream, but rather than stream writer, you use stream reader. And they show you the syntax for it right here. And here's an example. So if we already had that file that we created previously right here, that one that now looks like this, and it's not formatted at all, we could read it, then manipulate the way it looks. So notice we've now put headings in there, we've put delimiters between the fields, and we formatted the salary so that it's currency. And that's all shown in here. The idea, what's important with this, what's important is to be able to read and write files, not the fact that they're doing some formatting in here. So we already talked about this file position pointer, and what it does, as it says, is it holds the byte number of the next byte to be read. You can reposition this file pointer using seek. If you set it to 0, seek origin.begin, it's the beginning of the stream. Current is where you currently are in the file, and end moves you to the end of the file. So if you wanted to read, you might position it at 0, seek origin.begin, so you'd be reading from the beginning of the file. If you wanted to write to a current file, you might want to then send that one to the end, so you'd be writing to the end of the file. And they show some examples right here. All right, and it's kind of a neat program, the one that's here. I'm not going to go through it at all, but notice what it says. It allows you to enter information in. All right, it allows you to enter information in about what we just did here. In other words, about those employees. So it allows you to, it says, enter a minimum salary or $9.99 to quit. All right, so if the minimum salary is 50 grand, show me everybody who's making 50 grand or above. Now remember, what we had here was 42, 52, and 60. Well, 52 and 60 are 50 or above. If we change it from 50 to 55, that knocks out the one that's 52, so it's 60. If we put the minimum at 0, all three are listed. So there's a lot of different things that we can do with this. Disadvantages to writing to a text file: it can be read by anybody because you can open it up with any simple editor, so it's not secure. It's kind of tough, cumbersome, as they say, to constantly be writing this stuff and then a comma, etc. Now, it's even harder when you're working with objects, like the employee object that we worked with. So this chapter ends by talking about the process of serialization, which is converting an object into a stream of bytes, and deserialization, all right, which is putting it back together again. Now, I've given this example before. It's non-computer. Some people like it, some don't, but I'll say it anyway, because hopefully it'll hammer home the point. Years ago on TV, there was a TV show called Home Improvement that you might have seen. If you're young enough, you've seen it in reruns. If you're old enough, you might have seen it when it was on. Tim Allen was a hardware guy, or he tried to be a hardware guy. Al Borland was actually the hardware guy. The point is, in the last episode of the show, Tim's wife Jill had gotten her master's degree in psychology. For years, Tim had a TV show in Michigan that was called Tool Time. Well, when Jill, his wife, got her master's degree in psychology, she was offered, I believe it was a teaching position in Indiana. And Tim decided that what she had done her whole life was support him, so he wanted to support her. So he quit his job, and he wanted to, they were all going to leave together. And they were packing up the stuff in their house. When they were packing it up, Jill said, "Boy, I love this house," and they were going back and going over memories, and she said, "I wish we could take the house with us." And Tim went, as he always did, and thought about it. Well, what he did was he took the house and he hooked it up to a trailer, and they were going to literally move it. But imagine that they couldn't do that. So imagine that instead what they were going to do is they were going to take, let's say the house was brick, and they were going to take the house apart brick by brick. That's serialization. And if they moved it to Indiana and put the house together again brick by brick, that's deserialization. In much the same way, if you're sending something over the internet, if I'm sending a PDF that, let's say it's humongous and it's a gig, there's no way that that entire gig can be sent over the internet at one time. Instead, what happens is a serialization takes place where that document, that 1 gig document, is broken down into a series of what are called packets that hold pieces of the information. Then it's sent over the internet, and then on the other end, it has to be deserialized or put back together again. And that's what they're talking about here.